Welcome back to Maths in an Empty Classroom with me, Mr. Sutton. This is the second question from the activity Stretch the Function that I've been asked to go through. The purpose of this activity was to say that if we're evaluating an integral between -1 and 2, the integral of a function, and we want the answer to be 1, what value does the constant a need to take to make that happen? Now the function that we're doing it for in this question is this one here, x minus 2, 2x minus 1, x plus 1. So I've just raced through this very quickly. I've expanded out those brackets to get it into number x power form. I've got 2x cubed minus 3x squared minus 3x plus 2. I've then integrated that function to a half x to the 4 minus x cubed minus 3 over 2 x squared plus 2x, and I'm evaluating that between the limits of -1 and 2. When I substituted in 2, I got -2. When I substituted in -1, I also got -2. So when I did -2 subtract -2, I came out with 0. So the value of the integral between -1 and 2 is actually 0, which means for the purpose of the first part of this question, there is no value of a that we can use to make this 1, because there is no number that when you multiply it by 0, you get an answer of 1. So in the case of answering this, there is no value for a. However, when we come to look at finding or getting the area between the curve and the x-axis between -1 and 2 to be 1, that we can do. So we're going to look at that now, and it will give us an indication as to why this has actually come out as 0. So this is a cubic function. I've got my 3 brackets. I've got my 3 roots where it crosses the x-axis, 2, 0, a half 0, and -1, 0 there. So I'm going to plot that onto a graph. So it's going to go up through -1, back down through a half, and up through 2. So there's -1, 0. There's 1/2, 0. And there is 2, 0. And the area enclosed by the curve and the x-axis between -1 and +2 is the sum of those 2 areas. So you think, okay, well, that area clearly isn't 0. That area clearly has a positive value. What we've got to think about, though, is when we use integration to find areas, what happens when part of the curve is below the x-axis? Well, that bit comes out as negative. So what we actually have to do is we have to find this area separately to this area to find the total area enclosed by the curve and the x-axis. And the reason we've come out with an answer of 0 here is actually that this area and this area are the same. So what I would do is, rather than integrating between -1 and 2, I would integrate this function between -1 and +1/2, and that's going to find me this area here, which I'll call area A. Now, rather than going through all the notation of doing this, I know that when I sub in -1, I get -2, and I've just worked out off camera that when you substitute in a half, you get 17 over 32. So it would be 17 over 32, take away -2, which is going to be the rather beautiful 81 over 32. Then, to find this area here, which we'll call B, I would be evaluating the integral between 1/2 and 2. Now we know from before that when you substitute in 2, you get -2. When we substitute in 1/2, we get 17 over 32, which we're taking away, and that is going to give us -81 over 32. So as you can see, the reason this has come out as 0 is it's done 81 over 32 plus -81 over 32. So it's treated that area as positive and that area as negative, and because they're the same, it's come out as 0. But what I actually want is the total area. So my area would actually be 81 over 32 plus 81 over 32, which is 81 over 16. Now what that means is, if I want the area of this function to be 1, what I would have to do is if I would have to stretch it by scale factor 16 over 81, so that when you multiplied that, it came out as 1. So the function that I would need to use to create an area of 1 between these two limits here would be y equals the x minus 2, 2x minus 1, x plus 1, gaps left there deliberately, for 16 over 81. And if I did that, what would happen is it would stretch by a factor of 16 over 81, so it's going to squash it down. This area here would shrink, this area here would shrink, and the total area would come out as 1. Bonus points for guessing what the area of this section would be and what the area of this section would be if the overall is 1. Yeah, absolutely right, a half. That would be a half, and that would be a half. Job done. Hope this helped.